Let's go ahead and take a look at balancing chemical equations and identifying indications of chemical reactions. In every chemical reaction, there are several indicators that will let you know that a reaction is not just physical, but chemical. There are four main ones. Now, all four don't need to be occurring for them to be a chemical reaction, but these are just really good indicators that let you know that a chemical change has taken place. The first is the evolution of a gas. So anytime you have effervescing or bubbling occurring. The second is a precipitate will form. So that's a solid that forms in a solution by mixing two liquids. Next, color change. Now, color change can also be physical, but often color change is a good indicator of a chemical reaction. And the last, the production of or evolution of heat or light. Now, if something can get cold, that's also production of heat. It's just gotten colder and not hotter. So don't be confused that heat could be colder, endothermic, or hot, exothermic reaction. So what information can we gain by looking at a chemical equation on a piece of paper? Well, number one, you should definitely see the law of conservation of mass and energy, which means basically the total number of atoms are on one side, your reactants, are going to be the same amount on the other side. So the mass of the reactants is conserved in that reaction. The other thing is the type of chemical reaction that is occurring. And there are 5 different types that we're going to take a look at today. Let's go ahead and take a look at our first one. This is called synthesis. When you synthesize something, you make something. So you're basically combining 2 or more elements to form one new compound. If I was to look at just simple letters and not elements, I would have element A plus element B is going to form compound AB. An actual example would be sodium and chlorine. When I put sodium together with chloride, I form sodium chloride. Element A would be the sodium. Element B would be the chlorine. And my compound that I made is sodium chloride. Now, the opposite of that is decomposition. Decomposition is when you break down a product into 2 or more things. So it's the reverse or opposite of synthesis. So if I look at my letters again, I'm going to start with compound AB, and it's going to break apart into element A and element B. An example of this would be water. 2 molecules of H2O are going to break apart into 2H2 plus O2. We'll get closer to look into those numbers in just a minute when we begin balancing equations. Single displacement. When you displace something, it basically moves to a new location. It's also called single replacement, depending on the textbook that you're looking at or the resource that you might be reading. So here is where we have one element that's basically going to switch places with a part of a different molecule. Looking at the letters again, I have element A plus compound BC is going to yield or give off or make compound AC plus B. Notice that you have one element singled out on either side of the equation. That might be a good way to remember single displacement. So we have zinc plus hydrochloric acid. On the other side, I have zinc chloride plus hydrogen gas. So hopefully you can see 2 different molecules on either side, 2 different compounds, and 2 different elements singled out on either side of the reaction. Double displacement. Similar to the single displacement, except you're going to have 2 different molecules on either side. And again, you can see the word replacement there as well. Here's where you have 2 atoms exchanging places between molecules. Looking back at our letters, we have AB plus compound CD is going to yield compound AD plus compound CB. So you can see 2 different atoms have exchanged places between the molecules. So they each have different partners. Here's an example. Sodium bromide plus calcium fluoride is going to yield sodium fluoride plus calcium bromide. So you can see the fluorine and the bromine both switch places. Our last type of reaction we're going to take a look at is combustion. Combustion is when something explodes and burns off. Here's where you have some kind of fuel combined with oxygen, and it's going to yield carbon dioxide, and H2O. So you'll see here, my letters look slightly different. I have A plus B. A is my fuel, plus B is my oxygen, is going to yield carbon dioxide, which is CO2, and H2O. So we have some methane gas and some oxygen. Once there's some activation energy, is going to burn or combust and give off some carbon dioxide and some water. All right, let's take a look at balancing equation. Balancing equations are exactly what they sound like. They're equations that show a balanced amount of atoms for each element, both on the reactant side and the product side. So again, this will show what's called the law of conservation of mass, that what you have before a reaction, you will have after. Let's take a look at some examples. The first thing you want to take a look at is what elements you actually have. So let's start with our first one. Here we have nitrogen. And that little 2 here, that's a subscript that tells me I have 2 atoms of nitrogen. And same thing here, I have 2 atoms of hydrogen. So on this side, N2 plus H2. On the right side, I would read that N1H3. So let's start balancing the nitrogen. So if I was to balance the nitrogen, I would take, this side is 2. On the right side, there's only 1. So I'm going to place a number 2 right here. By doing that, this 2 gets distributed to the nitrogen and to the hydrogen. So now this side, the right side, I would read N2H6. So my nitrogens are balanced. My hydrogens on the right side, I have 6. On the left side, there are only 2. So what number times 2 equals 6? That would be a 3. So at this point, I would have a 3 there and I would be balanced. This gets a 1. So at this point, I am balanced. So if I was to look at my numbers, 1, 3, 2. Let's look at the next one. This one's a little bit more. On the left side, let's start with sodium. Na, well, Na1. On the right side, Na1. Back to the left side, Cl1, right side Cl2. That means I have to put a number 2 in front of NaCl. So now that 2, remember, gets distributed. Coefficients get distributed to everything that's in the molecule. So Na2, Cl2. So now I need to go back to my Na and make sure they're balanced. Well, on the left side, they're 2. On the right side, they're 1. So 1 times a 2 equals 2. Remember, the 2 gets distributed to everything that is after it. So the F on this side is also 2, but if I look back here on the right, it is also 2. You can add in your 1s, and so your number would be 2121. Let's take a look at another one. This one is a little bit more complex because you have a parentheses around OH on the right side. We'll get to those in just a moment. So again, let's start with our first element, Fe. On the left side, Fe1. On the right side, Fe1. So they're balanced. Next is chlorine. Left side, chlorine 3, Cl3. Right side, Cl1. So I have to put a 3 in front of sodium chloride. So at this point, I have 3 chlorine. But again, by doing that, that 3 gets distributed to the Na and to the Cl. So I have 3 Na on the right side. I need to have 3 on the left. So go ahead and add your 3 right here. But by doing that, that 3 gets distributed to the Na, to the O, and to the H. So if I look back on the right side, what I mentioned before, that OH3, so this little 3 gets everything inside of the parentheses. So H3, O3. But again, I added a 3 in front of sodium hydroxide, NaOH, that got distributed, so I'm balanced. At this point, you can add your 1s in. You're balanced. So your 4 numbers are 1, 3, 1, 3. Let's continue on. On page 157 in your lab manual are the balancing equation worksheet. It's the first one. So let's go ahead and take a look at this one together. NaNO3 plus PbO yields PbNO3 plus Na2O. What I would like for you to do is to pause the video, go ahead and try this one, and then go ahead and restart the video when you're ready. All right, let's talk through this one just quickly. Hopefully you are finished. And let's go ahead and add our numbers in, starting from the left-hand side. Na1, right side, Na2. So I know I need to match the NAs and put a number 2 there. My next element is nitrogen. Remember, this gets distributed to everything that follows. Na2, N2, O6. So I know I have N2 on the left side, but remember this 2 gets distributed to everything that is inside of the parentheses. N2O6. So my N's are balanced at 2. Oxygen, be careful here. Remember, 2 times O3 is O6, but remember, look what's here. There's a plus sign. So there's 6 oxygen right here, plus 1. That's a total of 7. So if I look on the right side, O3 times 2, that's 6, plus 1 is 7. So oxygens are balanced. Pb, lead, 1. Pb, lead, 1. Add your 1s in. And at this point, your balanced equation should read 2, 1, 1, 1. All right, let's continue on with the next one. All right, this one's a little trickier, and you'll see why in just a second. Take your time, pause the video, and come back when you're ready. All right, now that you're back, let's go ahead and work through this one together. Let's start with Ag. Ag is 1 on this side and 2 over here. So I would put a 2 here to start, and we're going to come back to that in just a moment. You'll see why. Next, iodine. We just put a 2 here, that gets distributed. So I2. On this side, I3. This is kind of called that crisscross applesauce technique. If I have a 3 and a 2, what's the first number they have in common with? And that would be 6. So how do I make these actually 6s? Well, I would actually have to put a 2 here to now match my iodine at 6, because 2 times I3 is I6. And then right here, I need to change this number. Remember, I need 6 over there. So I'm just going to put it up top. 6. So now my iodines are balanced at 6, but I just messed up the Ags, the silver. This is now 6. So I need to make 6 on this side. So I'm going to have to put a 3 here, because 3 times Ag2 is Ag6. All right, so the Ags are good, and so is the Is. My next one is the Fe. Fe2. Remember, you put a 2 here to make the 6, but Fe times 1 times 2 is 2. So Fe's are good. My next element, carbon, C3. Why? Because that 3 distributes to everything inside here. Okay, so if I have C3 on that side, I also have C3 on this side. My last one, O9. 3 times O3 is O9. Add your 1 in. Your numbers 6, 1, 2, 3. Let's do one more. Again, pause the video, and when you're ready, hit play. All right, so our last one here. Let's go ahead and work our way straight across. First element, carbon, C2. So I have to put, of course, to balance that, a 2 here, because 2 times C1 is C2. My next element is hydrogen, H4. I need to make 4 on this side. So I'm going to put a 2 here. So now I have H4. Now this is the first time we've come to this where one side of the equation is finished, which is great. That's the side you want to match. So our last element, of course, is oxygen. So let's look on the right side this time. 2 times O2 is O4. Don't forget this plus sign, because oxygen's in 2 places here. Okay, so 4 plus 2. Okay, so we have a total of 6 on that side. Let's look back on the left side. I have 6 over here on the right, and this side, I only have 4, okay? So let's pay attention. 4 plus what equals 6? So if I know that 4 plus 2 equals 6, I need 2 more oxygen on the right side. Now, I could put a 2 here, and that would make 6, but that messes the carbon and the hydrogen up. So the reason why you're not going to put a number 2 here, because then you're going to have to go back and rebalance everything, and you don't want to do that. This is the place you want to change because it's oxygen's all by itself. Again, if I have 2 here, 2 plus what equals 6? 2 plus 4. So how do I make this a 4? I put a 2 right here. So now I have 2 times O2 is 4, plus 2 equals 6, and so on balanced. Add in your 1, and you're finished. And that's balancing equation. Of course, continue working on the rest of the sheet. If you have any questions, please don't hesitate to reach out. I look forward to hearing from everybody.